Hello, and today we're going to look at how to measure mass using an analytical balance, which is just a fancy term for a scale that we use in the lab. And mass is one of the fundamental things that we need to measure on a regular basis in order to figure out how much of a certain material we have, or to measure out a specific amount of it. And so look around here, around the balance, we have lots of supplies that we need. We have the balance itself. We've got some weighing boats. We've got some big ones and some little ones that I can weigh solids into. And because I don't want to pour a powder right onto the top of the balance, that would be very difficult to work with and would make a terrible mess, and I wouldn't be able to get it off of there again. So I've got weighing boats for that. I have a brush here that's for cleaning the balance. If I spill anything, or if I see that someone else before me has spilled something in here, I can get all of that material out of the balance using the brush. And I have my solid that I'm going to weigh out. This is ammonium bicarbonate. It's a nice buffer that I use often in the lab. And I've got some scupulas that I can use to scoop the solid because I don't want to touch it with my hands. I want to use a scoop in order to move things from one place to the other. And the last important thing is that I'm taking notes, and I'm going to be recording a mass that I'm reading off of this balance, and so I need to have my notebook with me. If your notebook is a handout or a sheet that you're using in lab, you're going to want to have that with you. And of course, if you see, I'm working in the lab, so I need to be wearing goggles as well. So let's get started, and let's weigh out some of this solid. Here you can see my scientific notebook that I brought over to the balance. I've already started taking notes. I've written out what I'm going to do. I'm going to make an ammonium bicarbonate solution. My plan is to weigh out 0.8 grams of ammonium bicarbonate. My actual amount that I weigh out might not be exactly 0.8000 grams. It's fine as long as it's close to that 0.8 grams, it's okay. The actual amount I get on the balance can be more precise, and I'll write down all those sig figs right here. I left a line where it says actual amount, and I'll record that number here. I need to put the weighing boat onto the platform in the balance, but I'm not actually interested in how much that weighing boat weighs. So what I'm going to do is I'm going to tear the balance with that weighing boat in place in there. Notice that I closed the doors. When I take a reading with the balance, I always want all the doors closed so that a gust of wind or air currents don't affect the mass that's there on the balance. And it really does have an effect, and so it's good to have these closed before I record a measurement. Now that I have the weighing boat in place and the doors closed, the balance reads 0.723 grams, and that doesn't mean anything. I don't need this number. It's actually, I never tear the balance when I put it in there, so this number is meaningless. The one button you want to use very often on the balance that you're going to find yourself using is the tear button. So if I press tear, now this says 0 grams. And so now I know that I'm ready to put material into the weighing boat. Once you have this container teared on the balance, you want to start transferring your solid into it right away. If I pick this weighing boat up and move it somewhere else and then come back with new material in it, I cannot trust that this will still be teared. And the other thing is, if I take a new weighing boat and put it in there, I have to re-tear it again, because each weighing boat, you'd think that they weigh the same, but they don't. They have slightly different masses, and so every time you put a new weighing boat on there, you're going to need to tear it. And now I can transfer my solid into the balance. Here I have my ammonium bicarbonate. I'm going to take the cap off. I'm going to use a scupula to transfer this material. And so I can open the door up, and I want to be mindful that I don't have anything here that I wouldn't want to spill onto, because you just assume that I might spill something and I need to know what I'm going to be able to do after I spill it. So I have a clear area here, and I don't want to move the boat. I just want to drop my material right into it. I'm being very careful not to get any material outside of the balance, because that would still register on the balance, but it would be mass that's not in my weighing boat, which would be a systematic error. So right now it says 0.690 grams. I'm going to add a little bit more. 0.712. Do another little shake. 0.768. Oh, I'm getting close to 0.8. Remember, I wanted 0.8. I might just stop now, but maybe I just want a little. Okay, 0.832. As you can see, it's very difficult to get an exact number, but the thing is, you don't have to. That's why I have a line here for recording this mass. Okay, so you can see here, I've got that 0.832 grams, and I'm going to write that down right here, 0.832 grams in my notebook. You notice that my decimal point has a 0 before it. That's important to put that there, because otherwise it's very hard to see that that decimal point is there. It's really a requirement. And you notice that I've got 3 significant figures, 0.832. If I had more, I would add extra zeros after that. And so let's say in this experiment, I want this solid to end up in this beaker. The best practice would be to have your container that you want to transfer your solid into right here at the balance. Because if I pick this up and I carry this around the room, I could very likely spill some of it, and then my mass is going to be actually smaller than what I measured, and that would be a systematic error, right? And so I want to make sure I get all of that material into the beaker. This is now garbage, and I can throw that away in the garbage can. Also, my scoop that I used in order to scoop out this material currently has that solid on it. I'm going to clean this off with some clean paper towel before putting it back in here, because everybody else in the lab is going to assume that when they take a scoop out of here that they're getting a clean scoopula, and so we all need to make sure that that's the case. All right, so here is our solid, 0.832 grams. I recorded that I poured that solid into a 100 milliliter beaker, and I've got that over at my lab bench now. Let's say I want to do this again, but this time I want 1 gram. And I'm going to do it a little differently this time, just to show you how this could work. If, let's say, I want to transfer something into my container, but I can't do it, or I don't want to do it inside the balance. And so I can transfer something into a container outside the balance if I record the tare mass of that container. So I'm going to take a beaker, and I'm going to weigh the beaker empty. And then I'm going to add some solid to that beaker, and I can weigh the mass of the beaker plus the solid, and I can subtract the two to figure out how much solid I put into it. This is the other way you can measure masses with a balance. So in order to do this, I have the doors on the balance closed. Right now it says negative 6.95 grams. That number doesn't mean anything. I want to get rid of it. I'm going to hit the tare button, 0 grams. Now I can put my beaker in here. And you can see that the beaker is wiggling and rocking around because it's sitting on an uneven surface. I want to make sure that that's not moving. Okay, it's sitting still now. And I've got 60.735 grams. That's a lot of sig figs, but I need to record all of them in order for this to work out. So 734 grams. I've got all 5 sig figs there. But because I'm doing subtraction, I'm actually going to need all of them. All right, so there we go. That's the beaker mass. And now I can take the beaker out if I want to. It's important, though, that I make sure that this beaker is dry. For example, if it's wet, that liquid would evaporate and my tare mass would be wrong. All right, so let's say I want to, in this case, I'm going to weigh out 1 gram of salicylic acid in this container. Which is what I have written in my notes. And it's harder to do because I don't know, is that really 1 gram? I'm not sure. I'm just guessing, right? So obviously this method, when the container's not in there, I don't actually have a good idea of how much I just added, but now I can measure it. There's pluses and minuses, obviously, to this method. But all right, so I have this tared. It says 0 grams. I can put this back in here. I can see how much salicylic acid that was that I just weighed out. I'm going to set this aside for now with the scupula. And it says 61.581 grams. 61.581 grams. Well, let's see how good I am at eyeballing a gram. I'm obviously not totally correct here, but let's see how much solid we actually have in this container. All right, so I'm going to take my beaker, which weighed 60.734 grams. After I added solid to it, it weighed 61.581 grams. When I subtract the beaker mass from the mass of the beaker plus the solid, I get my actual amount, and that's 0.847 grams. So notice these numbers on the balance have 5 sig figs, but the difference between them only has 3 sig figs, because when you do subtraction, you're looking at the final digit. And so our limiting digit is the same. It's the thousandths place in both of these, which means my answer can go to this thousandths place here, which means because this one's a 0, that doesn't count. I have 1, 2, 3 sig figs in my mass. I actually have here 0.847 grams of salicylic acid. So it's not the 1 gram that I wanted, but I know how much I have in here. That's good enough for me for the experiment that I'm going to do. All right. So now I have my solid that I weighed out. I have all the numbers recorded in my notebook. Now I can leave and let someone else use this balance. After cleaning up, of course. I still have some salicylic acid on this scupula. I made a little bit of a mess here. Let me clean that up. I can put the clean scupula away. I'm going to double check that my containers here are closed and capped, because we don't want to leave open containers around to get contaminated, or sometimes people screw up the lids. These are all things we want to avoid. And I want to make sure, I don't think I spill anything. No, this looks clean in here. So I'm leaving the balance in a clean condition. I'm leaving the workspace clean. Good to go. Now I can go back to my lab bench and continue with my experiment and have lots of fun. Yay. And I hope that you have fun weighing things as well.